Now we'll try to see the parabola, right? This is a cone, right? And this cone, if we cut it parallel to the slant height, right? This line is called as the slant height in the case of cone. So when we cut this cone parallel to the slant height, right? After cutting this, you will get a shape somehow like this. We'll get a shape somehow like this. My shape is not very good because I'm not a drawing teacher. Right. Now, this shape is called as parabola. This will come somehow like this. Okay. This will come somehow like this, and this is called as parabola. Same like circle, for the study of parabola, ellipse or hyperbola, we require some component, right? And those components, what we need is, we need to draw this parabola, we require a fixed point and we require a fixed line, right? These are the two things that we require for drawing a parabola, right? Now, this fixed point we can name as focus. The fixed point is named as focus, and this fixed line is named as directrix. Directrix. Right? Okay, now in between this focus and directrix, exactly in the middle of this directrix and the focus, we need a third point. We need a third point, right? So that the distance of this point from the focus and from the directrix are same. Is it okay? Now let us draw a line that will be passing through this point and also the focus, right? Now this point is focus. Maybe we can denote it as S, right? And we can denote this point as M. Is it okay? And this fixed point, we can, this point which is the center point of S and M, we can denote it as V. Clear? Now remember that SV is equal to Vm. The distance of V from S and M are same. Now like this, if we can mark some few more points which is at equal distance from the fixed line and the fixed point, right? Maybe say this is the point which is at equal distance, this is another point which is at equal distance from S and also from the directrix. Similarly, we can have some few more points, right? These all the points are at equal distance from the focus and also from the directrix. In the downward direction also we can do the same thing, right? These are the 3 points which are always at equal distance from the focus and from the directrix. Now if we join these all the points, then we are getting a shape, and that shape is called as parabola. This shape is called as parabola, right? Remember here, these are the points. Let's join these two, few of them. This is a point, this is a line, right? And the distance of this point from S is the same as the distance from the directrix. So let us say this is the one. Then maybe we can have one more point. We can join this with this one, and then also with the directrix. We can name this as maybe M1, this point as M2, right? Now, again I'm repeating that this point is at an equal distance from S and M, right? This point also is at a distance, at an equal distance from S and M1. This point is at equal distance from S and M2, right? These distances may be different. These distances may be different, but the distance of this point from the S and also from M will be always same. Is it okay? Means, suppose if we name this point as P, this point as P. If this point is named as P, that means we will say this P S is equal to PM2. Is it very clear? So this distance, okay, now this point S, and at this point now we can draw a vertical line. We draw a vertical line, right? And say this point, this V is at origin. This V is at origin. We can mark the coordinate as 0, 0. You know the coordinate of the origin is 0, 0. And this point we will mark it as vertex. So this point is the focus. This line is the directrix, and this point is called as vertex. Is it okay? Now, as we know that this distance and then this distance are same, so suppose if this S is at a distance of A from the vertex, then the distance of this M from the vertex also will have to be A. Please remember here, this is a kind of number line. We can take this 2 line as the coordinate, right? And in the coordinate, we know that on the left side on the x-axis, in the left side on the x-axis is negative, and on the right side is positive. But still here I'm taking this as positive quantity only because this is a distance, and distance means it's a scalar quantity where we do not require the direction. So the distance of this M and the distance of S from the vertex is same. This is equal to A, right? Now that means this M, we can say this is at a distance of x is equal to minus A. Till now, what we have seen is this is the focus, this is the vertex, and this line is the directrix. Now, because this S, the focus is at a distance of A, so we can write the coordinate of this S as A0, right? This is because vertex and it is at the origin, therefore the coordinate of this vertex is 0, 0, right? And this directrix is at a distance of x to the power x is, this is the distance. So the equation for the directrix we can write as x is equal to minus 1. This is the equation, and here this is the distance. Is it well understood? This line which passes through the vertex and the focus and is perpendicular to the directrix is called as axis. Is called as axis. Is called as axis, right? And on the x-axis the value of y is always 0, therefore the name of this axis will become y is equal to 0, right? Now after this we will use the definition of parabola. Definition of parabola says that PS is equal to PM2, right? PS is equal to PM2. Now suppose the coordinate of this point is x and y, right? Now we are trying to derive the equation for the parabola. Is it okay? So using the definition of parabola, we can say PS is equal to PM2, right? Now using the distance formula, we are going to derive the equation for parabola. So PS, the coordinate of P is xy and the coordinate of S is A0. Using the distance formula for PS, we can write this as x minus A whole square plus y minus 0 whole square root over, right? Now we are trying to find the distance of PM2. Now with the distance of PM2, we have difficulty is we know the coordinate of P, but we don't know what is the coordinate of this M2. So here we are not in a position to use the distance formula, right? So how can we find the distance, this PM? For this we will use the concept of a distance of a point from a line, distance of a point from the line. For that we have the equation, distance of a point from the line, distance of a point from line. The formula we have is say this is PM2, right? Or maybe we can denote it as simply D, right? D. This is equal to AX plus BY plus C, right, over root over A square plus B square. This is the formula for finding the distance of a point from the line. Is it okay? Now we can use this concept here. This is the equation of the line. This numerator is the equation of line. And what we need to do is to find the distance of point from a line. We just need to replace this x and y by the coordinate of the point P. Is it okay? So using this formula, we are going to find the length of this PM. Therefore, the equation, now here the directrix equation is x is equal to minus A, right? To write it into this form, we can write this as x plus A is equal to 0. Now this becomes the equation of your line. So this equation of line, we can replace it in the numerator x plus A, right? And in the denominator, we can have a square plus b square. And you know, like a is the coefficient of x and b is the coefficient of y. In your this equation, we do not have y. Therefore, we need to just have the coefficient of x. And the coefficient of x is just 1. So write this as root over 1 square. Root over 1 square. Now, you know, like 1 is such a number, you square it also, its value will remain same. And then if you find the square root also, it will remain same. So, now we are going to solve it. Now, what we can do is to remove this radical sign, we need to square on both the sides. So, when we are squaring on both the sides, from the left hand side, the square root sign will disappear. And on the right hand side, the mod sign also will disappear. Is it okay? So, let us continue. This is a minus b whole square we can apply for x minus a. So this will become x square minus 2ax plus a square. This will simply remain as y square. On the right hand side, it will become as equal to x plus a whole square. That means x square plus 2ax and plus a square. Denominator will be 1, therefore we are not writing it. Now simplify this. This x square will be cancelled. Then a square and this a square will be cancelled. And now this minus 2ax on the left hand side and right hand side 2ax are like term. So we will send it on the other side. Therefore, your y square will be equal to 2ax plus 2ax. And this will become 4ax. Therefore, the equation of the parabola will become y square is equal to 4ax. And this is the required equation of parabola. After the derivation of parabola, we got the equation finally for the equation of the parabola, right? Equation of the parabola, we found it as equal to y square is equal to 4ax. This is the general equation of the parabola. Is it okay? Now, the parabola that we have drawn was something like this. Right? This is not now. This was the parabola that we have derived. No, this is the parabola for which we have derived the equation. But the parabola can be of other side, other type also. No, the parabola can also be drawn facing to the left side. Right? So in this case, the equation of this parabola will become little different. Similarly, we can also have the parabola facing in the upward direction. And then we can also have parabola facing in the downward direction. That means altogether we have 4 types of parabola, right? This parabola we can call this as right-handed parabola. This parabola we can call it as left-handed parabola. This parabola we can call it as upward parabola. And this parabola we can call it as downward parabola. Is it okay? Now, we will see that this is the equation for the left-hand parabola. This is the equation for right-hand parabola. We derived the first parabola as a right-hand parabola. So this was the equation for the right-hand parabola, right? Similarly, if we have left-handed parabola, what would be the equation, right? So the simple thing will happen is this is y square and this in place of positive because on the number line towards this side is positive, right? That is why we took this as positive 4ax, and if it is left-handed parabola, then the equation of this will become minus 4ax. This is the equation for the left-handed parabola. Similarly, for the right-handed parabola, our equation now, because the axis is changed, for right-hand parabola and left-hand parabola, the axis was x-axis. Now, for the upward parabola and the downward parabola, the axis is along y. The axis is along their y. And therefore, there will be a major change in the equation of the parabola for the upward parabola and for the downward parabola. What will happen is, in this same equation, this y and x will interchange the position. Right? So, for the upward parabola, in place of y square equal to 4ax, now this equation will become x square is equal to 4ay. Rest everything will be same. This x will take the portion of y and y will take the portion of x. This will become the equation of parabola for your upward parabola. Likewise, for the downward parabola, we will have the equation as x square is equal to minus 4ay. This is the equation of downward parabola. Now, along with this equation, we also need to know about the changes in the coordinate of the, what will be the coordinate of the focus, what will be the coordinate of vertices, and another thing that I've missed to tell you is something is called as lattice rectum, right? For the lattice rectum, we can just understand this from the circle, right? From the circle, suppose this is a circle. I'm very sorry, this I could have done it a little before, but then never mind. This is a circle, right? In the circle, you know that you can, if you draw a line like this, then this line is called as a chord. This line is called as a chord. So chord is a line segment that joins 2 points of a circle. It is called as chord, right? And like this, we can have infinite chord in a circle. We can have infinite chord in a circle. You can join any 2 points in the circle, and that will be a chord. But there will be one chord which will be passing through the center. So when you draw a chord that is passing from the center, this chord is a special chord, right? And this special chord is named as diameter, right? Similarly, in the case of parabola also, we can have line joining the 2 points of a parabola, right? We can have infinite line joining the 2 points of a parabola, right? These all the lines which join 2 points of a parabola is called as double ordinate. Double ordinate, right? And there will be one ordinate that will be passing through the focus. This is S, focus. There will be one double ordinate which will be passing through the focus, and this double ordinate which passes through the focus is called as lattice rectum, right? And the length of lattice rectum is always 4a. After this, we will see what is the difference between all the outcomes of the parabola for the left-hand parabola, right-hand parabola, upward parabola, and downward parabola. So I'm going to explain you about all the values. Now we will discuss about all the important terms that we have seen in the parabola, and for the different type of parabola, left-hand parabola, right-hand parabola, upward parabola, and downward parabola, right? As you can see the table, right? The first column that you see, y square is equal to 4ax, this is the right-hand parabola. Second column belongs to left-hand parabola. Third column belongs to upward parabola. And fourth column belongs to downward parabola. This, now we can see that what is the axis. Axis for the right-hand parabola and left-hand parabola is same, y is x-axis. And on the x-axis, y is always 0. Therefore, the name of x-axis is always y as equal to 0. So these are the things that we need to remember, because in the question they will ask us to find out all this information. The detailed information of the given equation is find out the axis, then directrix, then vertex, then focus, right? And then the equation of lattice rectum or the length of lattice rectum. This anything can be asked. So we need to have this table. It's not necessary to memorize, but make sure that when you solve the questions, keep this table in front of you, right? And then the question can be easily done. So for the upward parabola and for the right-hand parabola and left-hand parabola, the axis will be same because it is along, the axis is along the x-axis. Therefore, the name of that axis will be y is equal to 0. Similarly, for the upward parabola and downward parabola, as you have already seen that the axis is along y-axis. Therefore, the name of that axis will be x is equal to 0 for upward parabola as well as for downward parabola. Both are same. Directrix for the right-hand parabola is x is equal to minus a, and then the left-hand parabola, the sign will change, x is equal to a. So these are the things that we have to keep in mind, where it will be negative and when the sign will be positive. Is it okay? Then vertex for all the parabola, whether it is a right-hand parabola or left-hand parabola, upward parabola or downward parabola, the vertex is 0, 0. Likewise, focus for the right-hand parabola is a0, left-hand parabola is negative a0. Then for the vertical parabola, for the upward parabola, the focus will be 0a and it will just shift. The axis will just shift. Now, all these tables that you see, right, the most important thing is the vertex. right? These are all the values of all the given informations: axis, directrix, vertex, focus, and so on, right? On the basis of the vertex, because the location of the vertex is at origin. When the vertex is at the origin, then the values of all the components, axis, directrix, and vertex, will be according to the table. But if the vertex is not at the origin, in that case, the values for axis, directrix, and all will change, right? Then in that case, we will use the different form of equation of parabola, and we call it as vertex form of parabola. So when that question comes, I will explain you and I will show you the equation, and also we will solve the questions. Now, after understanding all the component and important information about the parabola, we are finally entering into the question. So first of all, we will have a question number 1 of exercise 12a. As you can see the question on the board, find the equation of the parabola whose focus is at 10, 0 and the directrix is x is equal to minus 10, right? So using the definition of parabola, let us draw the diagram for this one. It will be more easy. We have the focus and we have the equation of the directrix. This is the focus, this is the focus, and then the coordinate of this focus is given as 10, 0, and the equation of the directrix is given as equal to x is equal to minus 10. Is it okay? Now from here what we can do is we can write down the equation of the directrix. So it will become x plus 10 is equal to 0. This is the equation of directrix that we are going to use, and this is the coordinate of your focus. Now you can draw a parabola, a curve that is passing through the center of this directrix and the focus. On this parabola, we can mark a point P whose coordinate can be assumed as x and y, and then drop a perpendicular from P on directrix. Is it okay? And this point we can mark it as M. This is P, and then the focus can be named as S. Now this is the diagram. With this diagram, it will be very easy for you to find the equation of the parabola. Now we are going to use the definition of the parabola. Using definition of parabola, right? What it says is PS is equal to PM. PS is equal to PM. This is according to the definition of the parabola, right? So PS, now we can find it out using the distance formula. It will become x minus 10 whole square plus y minus 0 whole square root over, and then on the right hand side we can use the distance formula, right? Finding the distance of a point from the line. The formula is equation mode of equation, that is x plus 10 divided by the sum of the coefficient of x and y. Here we have only x, therefore we can have 1 square, right? Now as usual, we will remove the radical sign by squaring on both the sides. So we are squaring on both the sides, squaring both the sides. What happens is when you square both the sides, on the left hand side the radical sign will disappear, and on the right hand side the mode sign will disappear. This is the benefit of squaring on both the sides. So from the left hand side we are getting this as we can expand x minus 10 whole square by using the a minus b whole square formula. This will be x square minus 2ab, that is 20x, and then b square, that is 100, and this is y square. Simply y minus 0 means y, and square of y is y square. On the right hand side we are going to square it. So x plus 10 will be squared. A plus b whole square we can apply. This will become x square plus 20x plus 100. Denominator will be simply 1, therefore we are not writing it. Now we can simplify. This x square will cancel this x square. This 100 will cancel this 100. Now minus 20x and plus 20x are the like term, therefore they can be kept together. Therefore you get y square as equal to minus 20x will go to the other side, will become positive x. Therefore 20x plus 20x will become 40x, and this is the equation of your parabola. Now we are taking question number 5, Roman number 1. This question is find the equation of the parabola. As you can see on the board, find the equation of the parabola whose focus is at 1, 1, and the equation of the directrix is x minus y minus is equal to 3. Okay. So once again, let us draw the diagram. Okay, so for here we will take the focus and then we will draw the directrix, right? The coordinate of the focus, we are given is at 1 1 1 1, and the equation of the directrix is given as x minus y minus 3 is equal to, is equal to 0. This is the equation of the directrix given. Now, to find the equation of the parabola, we are drawing the parabola here, and then on this parabola, same as previous question, we can mark a point as P, and then the coordinate of that P can be assumed as X and Y. Then join this P to the focus. This focus is named as S, and then from P we can draw a perpendicular on the directrix and mark this point as M. Right? Now, using the definition of parabola, right? We can write as PS is equal to PM, right? Mode of PS is equal to mode of PM. Now, PS can be calculated x minus 1 whole square plus y minus 1 whole square root over it. And then PM we can write as the equation is x minus y minus 3 over the coefficient of x and then y. It will be written as 1 square plus 1 square. The coefficient of y also I am writing as plus 1. This is because we are squaring it. So even if the coefficient of y is negative, it will turn into positive. That is why I am writing this as positive. So don't be confused. Now next step is squaring both the sides. Squaring both the sides. Now the root sign from the left side will disappear, and from right hand side the mode sign will disappear. And then we are expanding x minus 1 whole square, that is x square minus 2x plus 1. Then y minus 1 whole square is y square minus 2y plus 1. And then on the right hand side we can apply a minus b, a plus b plus c whole square formula, right? So we will have the square of a square plus b square means y square plus c square means 3 square, and that is 9. And then the product of the first two term, that is minus 2xy. Then product of second and third term, that is plus 6y. And then the product of first and the last term is minus 6x, right? In the denominator, it is 1 plus 1, 2, and then the root sign is disappeared, so it remains only as 2. We can do a cross multiplication. This is 2x square minus 4x. 1 plus 1 is 2. So this is equal to 4, and then y square will become 2y square minus 2y will become minus 4y. On right hand side we have x square plus y square plus 9 minus 2xy and plus 6y minus 6x. Now shift all the terms to one side, left side, and then simplify. 2x square minus x square will become x square minus 4x, and this minus 6x will become positive. So therefore this will become plus 2x. And now we will write this as plus 2y square minus y square will become equal to y square, then minus 4y, and this 6y will become negative 6y, so it will become total minus 10y. Then we have 2 minus 2xy will become plus 2xy, and this plus 6, and then here we have 9. 9 will come to this side, will become minus 9, so 4 minus 9 will become minus 5 is equal to 0, and therefore this is the equation of our parabola. Now we are moving to question number 6. Question number 6 is the vertex at the origin. And the axis along the x-axis and passes through minus 3, 6. Means find the equation of the parabola whose vertex is at the origin and the axis is along the x-axis and passes through negative 3 and 6. Let us draw the diagram and then try to understand what the question says. This is question number 6. Okay. Now let us draw a, what do you say, draw a coordinate, because the vertex is said to be at the origin, right? So this is the vertex of your parabola, right? And the coordinate of this point will be 0, 0, right? This is vertex. The vertex is said to be at the origin. When the vertex is at the origin, then there is not much difficulty. Please remember that. And now there is a point. This parabola passes through a point, and that point is negative 3 and 6. Negative 3 and 6. So x is 1, 2, 3 negative, and then 6 somewhere here up, right? This is one point through which the parabola is passing. That means if we draw the diagram, then because the parabola is passing through this way from the point, and then the vertex is this, so the parabola is somehow like this, right? This is the parabola. Now when you draw the diagram, you get a very clear picture that what kind of parabola is this, right? This parabola is a left-handed parabola, and you know what is the equation for the left-handed parabola. This is left-handed parabola, left-handed parabola, and the equation for the left-handed parabola was y square is equal to negative. If it is left hand, then it is negative. Then 4ax. This is the equation of your parabola. Now, the coordinate of this point is negative 3 and 6. Right? We need to complete this equation. This is the equation of the parabola. We need to complete it. Now, this equation can be completed only by just having the value of a. Right? Now, since this parabola is passing through this point, therefore, this point must satisfy this equation. So by substituting the value of this point in the given equation, we will calculate the value of a, and then finally we can have the equation of the parabola. So we are going to put it. So substituting negative 3 and 6 in the given equation, right? Now, here your value of y is 6, so 6 is square, minus 4a, and x is negative 3. When we simplify, this negative will become positive, and this is 4, 3 is a 12, so 12a, and this is 6 is a 36. 36 is equal to 12a. As a result, your a will be equal to 36 divided by 12 is equal to 3. And therefore, the required equation is, required equation is what? Y square is equal to minus 4. A we calculated 3, and then x. Therefore, y square is equal to minus 12x. This is your required equation of the parabola. With this, thank you so much for watching the video.